Dear students, I am Dr S B Sawarkar, Professor, Department of Physics, Sri Shivaji College, Akola. I welcome you all for our first lecture. In this lecture, we are studying about the unit number 5, which is based on the elasticity. In this lecture, we cover the following points: elasticity, plasticity, rigidity, stress, strain, and types of strain. Let us first discuss about the concept of the elasticity. When the suitable external force is applied to the material body, there is a change in shape, size, or both. It means due to the change in shape and size of the body undergoes deformation. The change in shape and size of the body under the action of applied force is called deformation, and applied force is called deforming force. It's called deforming force. Deforming force. When this deforming force is removed, the body regains its original shape and size. This property of the body, it is called elasticity. Thus, let us see what is elasticity. The elasticity, the property of the body, by the virtue of which body regains its original shape and size. Original shape and size on removal of deforming force is called elasticity. And the body which possesses this property, it is called elastic body. Elastic body. So this is about the elasticity. If there is a permanent change in the shape and size of the body, that is, body retains the deformed shape and size even after removing the deforming force, then such a property of the body, it is called plasticity. And the body which possesses this property, it is called plastic body. It is called plastic body. So in this case, in case of plasticity, when the external force is applied to the body, deformation takes place, and deformation produced in the body is permanent. No body will recover its original shape and size even after removal of the deforming force. Now let us discuss about the concept of rigidity. If there is no change in shape or size of the body when external force is applied, then such a property of the body, it is called rigidity. And body which possesses this property, it is called rigid body. It is called rigid body. Thus, when there is no change in shape and size of the body which takes place when when the deforming force is applied, then such a body, it is called the rigid body. The property, elastic property, or perfectly, say we may say about the perfectly elastic body, perfectly plastic body, or perfectly rigid body do not exist in nature. Let us discuss about stress. When a force is applied to the body, the particles of the body undergoes displacement under the action of the applied force. Due to the displacement of particle, internal forces of reactions are set up within the body, and these internal forces of reaction have a tendency to bring the body back to the original condition. That is, it has tendency to regain the original conditions of the body, or to recover the original conditions of the body, and therefore these internal forces of reaction produced are called the restoring forces. Restoring forces. This restoring force is equivalent opposite to the applied force. So let us define what is stress. Stress means this internal force developed per unit area. Stress means the internal force developed per unit area is called stress. Or in terms of restoring force, we may write the definition as the restoring force per unit cross-sectional area is called stress. So stress is equal to restoring force divided by cross-sectional area. And as restoring force is equal to the applied force, so we may write stress as the applied force divided by cross-sectional area. Let's say A is applied force, F is applied force, and A is the cross-sectional area of body, then stress is defined by the relation F by A. So stress is equal to F by A. Then about units of stress. What are the units of stress? Units of stress. So stress means F by A. So first we write SI unit of stress. Unit of force in SI system, it is Newton, and force unit of area is meter square. So SI unit will be Newton per meter square. Similarly, its CGS unit is dyne per centimeter square. Let us find the dimensions of stress. Dimensions of stress. Dimensions of stress. So dimensions of stress. So stress is nothing but F by A. So dimensions of stress will be dimensions of force divided by dimensions of area. So what about the dimensions of force? As we know, force means mass multiplied by acceleration. So dimensions of force is equal to dimensions of say mass and into dimensions of acceleration. So dimensions of mass is m to the power 1 and dimensions of area is nothing but the rate of change of velocity. So it is L to the power 1 t to the power minus 2. It means here dimensions of force will be m to the power 1 L to the power 1 t to the power minus 2 and the dimensions of area will be, area means here length into breadth, means it will be L square. Hence we have the dimensions of stress as dimensions of force means m to the power 1 L to the power 1 t to the power minus 2 divided by dimensions of area L square. So it will be m to the power 1 m to the power 1 L to the power 1 minus 2 means minus 1 and t to the power minus 2. So dimensions of stress will be m to the power 1 t to the power minus 1 L to the power minus 1 and t to the power minus 2. So this complete discussion of the stress. Now let us discuss about strain. We know that when the force is applied to the material body, there is a change in shape or size of the body. It means deformation takes place in the body under the action of force, and deformation produced is directly proportional to the original dimensions of the body. So hence we can define the dimensions of strain. So the definition of strain is here the change in dimensions per unit original dimension. The change in dimensions per unit original dimensions is called strain. Change in dimension per unit original dimension is called strain. So it is simply the ratio of change in dimension to original dimension. The strain has no unit, it is merely a number. So strain is a unitless and dimensionless number. Let us talk about the types of strain. There are 3 different types of strain because the change in dimensions of the body may be in the form of change in length, either change in length, change in volume, or change in shape or shear of the body, as dimensions may change by 3 ways: length, volume, or shape or size of the body. Hence there are 3 different types of strain. So let us write here 3 different types of strain. First type of strain, it is called tensile or longitudinal strain. Second one called volume, or it is also called bulk strain. And third one, it is called shearing strain. These are the 3 different types of strain depending on change in the dimensions of the body. So let us discuss about the first type of strain, tensile or longitudinal strain. If we consider a simple example of a wire whose one end is fixed to the rigid support and load is applied at the free end of the wire, if L is the original length of wire and delta L be the change in its length under the action of the force. So here we can define the tensile strain or longitudinal strain. So it is defined as the change in length per unit original length. The change in length per unit original length is called tensile strain. So we can write tensile strain as it is. Tensile strain means here it is the ratio of change in length divided to the original length, that is delta L by L. Then second type of strain, it is a bulk strain or volume strain. It is the change in volume per unit horizontal volume, change in volume per unit original volume of the body, and therefore it is called a volume strain. Let us consider a simple, say, cubical body which is subjected to a force. This is a cubical body, and force F is applied perpendicularly over an area A of the body. Then the volume, if say V is a original volume of the body and delta V is the change in its volume, then volume strain can be expressed as the change in volume divided by original, delta V by V, change in volume divided by original volume. This is second type of strain called volume strain or bulk strain. Then third type of strain, it is called shearing strain. So instead of applying the force here perpendicularly over this area, if we apply the force tangentially over an area A of the body, there will be change in the shape of the body. Look at this diagram. This force, this is a cubical body. Force is applied to this body tangentially. However, its base is kept fixed. Because of application of this force here to the upper this face of the cube, the shape of the body will change. Look at this diagram here. A, B, C, D is the face, and after application of force here tangentially, the point A will get displaced to A dash and B will displace to B dash, so that its shape will change. And therefore, so this strain is produced. This type of strain, it is produced by a tangential force acting on one of the surfaces of the body when opposite surface of the body is kept fixed, and it is simply measured in terms of an angle through which the line which was initially perpendicular to the fixed base is displaced. Let us now consider here this face ABCD, and it is displaced point here. So if we apply the force tangentially, this cubical body is, if it is supposed to be composed of different parallel layers, each layer will get displaced from its normal position, and the displacement is proportional to the distance of the layer from the fixed base. Maximum displacement will appear in case of an upper layer and lowest displacement of the layer which is in close contact with the base, fixed base. So if here we can define this shearing strain as, the shearing strain is the ratio of the lateral displacement of a layer to the distance of a layer from the fixed layer. So it is the ratio of lateral displacement of a layer to its distance from the fixed layer. So we can write the displacement shearing strain as, shearing strain as this the lateral displacement of any layer, lateral displacement of any layer divided by distance of a layer from fixed layer, Here in diagram, lateral displacement is represented by small d, and the distance of this layer from this fixed layer, that is bottom, it is capital D. Small d by capital D represented by theta, this angle theta, which is called angle of shear or shearing strain theta. It is called shearing strain. So theta equal to small d by capital D, it is called the shearing strain. Okay, let us stop here. Thank you.